Hello, my name's Chris Dewdney. Back in 2010, I was in charge of bringing back physics to the University of Portsmouth after a period of no recruitment to physics degrees. So in 2010, we were faced with the wonderful opportunity to create brand new physics degrees. This was a wonderful opportunity to embrace good practice that we found elsewhere and to ensure a modern degree that could provide graduates for industry and research, graduates that could add value in employment from the start. So it was clear to us that from the start we needed to embed what has come to be known as employability in all aspects of our degree. So one of the first things I did was to form an industry advisory board. Second thing, which was obvious we had to do, was to engage with the higher education community. Since 2010, I think it's fair to say that our career professionals in the university have developed a very strong basis, and obviously it's a good idea to use their expertise as much as possible. And of course, last but not least, one has to engage the students in the process to understand how they think and how they interact with different of the degree. So what did we think we needed to understand through dialogue with our industry advisory board? Well, we needed to know what the current demands of employment were, what indeed was the impact of a physics degree in adding value in employment, the nature and value of today's employability skills, the value of employability from the employer's perspective, and the need to provide suitable learning opportunities within the physics curriculum that would develop skills for wider professional practice. So the employers also had an impact in the way we designed the curriculum. It was clear to us from our discussions that computational physics and computational methodologies in general were very, very important. We took a mathematical modelling and problem solving approach in these computational modules, and in our laboratory work at level 4 and 5 we introduced a modern approach using computer-based data acquisition and instrument control right from the start. We also have, I think in common with many physics degrees, possibility of a year in industry. In some ways this has proved the most problematic element of our degrees so far, due I think to the competitive nature of year in industry schemes. There's a lot of SMEs in our area, but they are relatively low budget operations and often can't afford to take on students for a year. And of course we needed to establish the reputation of our courses in order to attract industry, and I think that is something which we're making a lot of progress on. Through SEPNet we were able to offer the students 8-week summer placements, but in fact the number of these placements that we were able to secure for our students was relatively. So we've had group projects running with some of our industrial colleagues. I think it's fair to say that not by any means all of our students are able to take these group projects, and in fact they take a lot more organising and it's very time consuming to engage with the employers to set these things up. So a couple of examples here, the one on the right where we had a student working on the remediation of radon gas for DSTL, and also another one on the left here working with the medical physicists at the hospital. And this is very much, I think, the most important part of our interaction with industry. So I mentioned engaging with the HE community, and of course there's a lot of good practice elsewhere in the sector, and I engaged with many of these groups in order to find out what they were doing and how to best develop our courses to embed the employability. We now incorporate in our credit rated units sessions delivered by our professional employability department who will train students in writing CVs and letters of application. So lastly, we needed to make sure the students were on board with what we were doing, and again we started right from the start with our induction conference, where we had short presentations from our previous students where they can actually see students who are really fired up by their physics. And I think it's inspiring for them to see that. They can see where they may well be going. Credit rating the work, I think, is very important because that clearly sends a signal to the students that this is something which is significant, it's going to count for their assessment. So I think attempts to try and do this sort of extracurricular outside of credit rating are doomed to failure. The active learning and problem-based approach to learning, I think, again, really sets the students going. You know, the more you give them the opportunity to develop themselves, the more they take in general. I think they benefited greatly from exposure to physics-trained industry professionals, and I think students, the ones who worked with our employers on projects, have actually benefited enormously through that, and they get very enthusiastic about the work as they can see it's authentic, it's actually taking place in a work environment which is going to be of value to the students.